Hello, this is Divya Lama. I'm from Tezpur University. Currently, I'm pursuing integrated BSc B.Ed course to the Department of Educations. In this video, I'm going to discuss on the teaching of arithmetics, in which I have taken the topic teaching of ratio for the fulfillment of the course as a first sessional test. So let's start the video. Here we start the topic, that is the teaching of ratios. For teaching the topic, that is the ratios, we first require some previous knowledges, that is the division, multiplication, fractions, and laws of fraction. It means that the students must be familiar with these topics. Then we can proceed to teach ratio. So first, the main objective of teaching ratios and proportionals is to understand the teaching of arithmetics in the context of primary and secondary education, to explore effective teaching strategies for teaching ratios and proportions, to discuss challenges students faces in learning these topics, to examine curriculum alignment with ratio and proportional concepts. So basically, how to start the teaching process in ratio is like, first we have to relate the ratios, the and the content with the real life situations. Like for example, it can be start with the questions like, how many hours do you spend in studying and playing games in a day? So if, for example, if it is 2 hours studying and 4 hours in games, then the ratios of study hour to playing games hour will be 2 is to 4. So this we have to make them understand that it means for every 2 hours you spend studying, you spend 4 hours of playing games. So through this example, the students will relate the real life with the content, that is ratio. Then we shall proceed to our content. After giving so many examples like that, that is in the previous slide, we can proceed to the main context, like understanding the ratio. Ratios are used to compare the numbers of one thing to another. It is written in the form of a by b, which is read as a to b. To understand them properly, we will take some examples like the ratios of the numbers of apples to the numbers of bananas is 2 is to 5. Here you can see that 2 apples are given and the rest of 5 bananas are given. So through this kind of example, they will be able to relate the content. Then we proceed to the different ideas of ratio. There is different types of ratios, because we know that there is part to part ratios, part to whole ratios, and ratio as a fraction. These are the different types of ratios. So with the example of this, like the 2 apples and the five bananas, we can make them understand the types of ratios, like relating the real life with the content. It can be make them understand properly. Starting with the first type, that is the part to part ratio. Part to part ratio is means that comparing one part to another part. So you can see, like we take an example of three basketballs which is in yellow color, and the one and the eight basketballs which are in a different, like orange color. So so this makes a ratio like 3 is to 8. There are three volleyballs for every 8 basketball. With the proper visualization of these examples, they will able to understand the part to part ratios. So you can give many examples to and make them understand the part to part ratio. So we proceed to the next type, that is the part to whole ratio. So part to whole ratio means comparing one part to the whole or a total quantity. So I have taken an example. You can see that there is three basketballs which is in yellow color, and the rest is eight basketballs in orange color. So there are three basketball and 11 in total. So you can give the ratios as 3 is to 11. So it is different for the part to part ratios. Like in part to part ratio, the ratio is 8 is to 11, and here the 3 is to, sorry, it was 3 is to 8. Here it is 3 is to 11. So basically it means that there are three volleyballs which is in yellow color as compared to the total balls, that is 11 in number. So showing these examples, we can relate the content with the real life things. The next is the ratio as a fractions. We can express ratio as a fractions. So with the same examples, there is three balls and the three and the eight other balls. There are three volleyballs and 11 balls in total. So it is like 3 is to 11, and there are eight basketballs and 11 balls in total. So 8 is to 11. So different fractions. The numerator shows the left sides while the denominator shows the right sides. Now let's come to the difference between the ratios and fractions. So after explaining the content of the ratios, so we must make sure that they have a clear understanding of the ratio between difference between the ratio and fractions. The first is that ratio between two quantities says, say P and Q need to be expressed in the form of their own language of fractions such as P by Q. Ratio can be effectively used for comparing non-similar object or quantities like object measured with different units. However, here we cannot compare them by expressing through fraction as the object and units compared quantities are non-similar. Means that for the fraction, the units and quantities must be similar. The third is the ratio can be can use 0 as the second entry, like 5 is to 0 for conveying the existence of 5 candles to 0 green candles in a particular package. Fraction on the other hand cannot define with a 0 denominator, and thus here we cannot express this comparison as 5 is to 0. Then other difference between ratio and fraction is the ratio are not always rational. Fractions, on the other hand, are essentially rational numbers because any fraction is equal to the division of two integers. The last is the ratio can be combined in unique way as under 3 is to 5 plus 2 is to 75 is to 12, suggesting that if has hit successfully 3 targets out of 5 in the first chance and 2 out of 7 in the second chance, he can be said to let 5 targets out of the 12. However, fraction cannot be combined in the similar way as 3 by 5 plus 2 by 7 is not equal to 5 by 12. So after explaining these types of ratios, we will give some checkpoints tasks like this. You can express the example like this. Express the ratio of organs to lemon into different types. So first question you can see, the second is also and third is also. So with this questions we will able to understand the or evaluate the understanding of the students on the topic. So here you can see the checkpoint task answer key, where 7 is to 10, 7 is to 17, and friction is this. Then next is the we move to the equivalent ratio. So the equivalent ratio refer to two or more ratios that have the same values. So we, for example, if we take 2 is to 6, so if it takes 2 is to 6, and if it is the twice of 1 is to 3. So multiplying or dividing both part of a ratio by same number will result in a equivalent ratio. So this can be shown with another type. Like we take example as 1 is 10 is to 100, then it becomes 10 by 10 by 100, which is 1 is to 10. Both are similar. So for this, the previous knowledge of multiplying and division is important. So we will move to this part. And after that, we will move to the method of comparing ratios. So there are two methods mainly, that is the unitary method and the common multiple method. In the unitary method, technique used to find the value of single unit from a given multiple. For example, if we take like the ratio, if we take there are 10 pens and 100 pencils, so it becomes the ratio as 10 by 100, that is 10 pen to pencils. So it is 1 is to 10, which means that for every 10 pencils there is one pen. So through these examples we can make them understand the unitary method. The common multiple method. In this method, we first try to find a common multiple of one of the units for the ratios to comparisons. For example, if we take an example like Rita won 16 of 20 games of badminton played by her during a particular sessions, and Preeti won 80 of 25 games of badminton played in the same sessions. So tell me which of these perform better in the matter of winning the games during the session. For us, for this finding the betterment of the game in between these two individuals, we first find a common multiple. In fact, the lowest common multiple LCM of 20 and 25 is 100. We therefore scaled each of these ratios so that the second number is 100. Thus, by multiplying the given and number by the 5 and 4, we can obtain these ratios in the following form. 80 is to 100 played, 81 is to 100 played, 72 1 is to 100 played. Definitely here 80 is the greatest than 72, meaning that Narita has performed better than PT in matter of winning the games during the session. So here I have to end up my video, and for these examples we will relating with real life, it will be easier for the students to understand the concepts. So here I have to end up my video, and thank you.